right, guys. For today, we're looking at all the properties of exponents. So all the things that you just did for homework on Friday that we just went over, we're going to use all those properties today. Okay, so real quickly, we'll go through them one more time so we can kind of go over what all the properties are and how they work. But then we're going to look at some problems that are a little more complex than what you guys were working on that assignment. Okay? All right, so all your properties, we'll kind of go through these piece by piece. All right, so the first one, the power of a power. Oh, I actually went down two, didn't I? Sorry about that. There we go. Product of powers property. Now, there's these big fancy names on every single part of this. Do I expect you to know the names? No, I don't. I think I might have mentioned in here, or might have been my other class, that we don't do proofs at all this year. Okay, so there's no proofs. For me personally, as long as you know how to do the math, I don't care if you know the fancy name for it. I really don't. As long as you understand how it works. So in other words, this is that very first thing that we just talked about. It's when they have the same base and you're being multiplied, you add their exponents. Right? So if I had like x to the fourth times x to the third, you would tell me that was x to the seventh. You would just add them. Okay? So that's all that's telling you. Do you ever multiply those bases together? No. You just find the matching ones, they come together. Okay? Right? Power of a power property. Okay? When you see parentheses and something outside of it, what's your first instinct to do? Multiply, right? You want to distribute. Hopefully at this point that's like your instinct. It's the same idea, right? But exponents only multiply to other exponents. Okay? They only like their own kind. So when they distribute in, they're going to actually be multiplied. So if I have x to the third, and that's to the fourth, what would that be? X to the 12th. Okay? Probably the number one thing students mess up is they multiply an exponent by the base number. Exponents only like their own kind. Okay? Exponents only go to exponents. Right? Power of a product. So same idea as the one up here, but it distributes to everything, just like you always distribute. But if I don't see an exponent, what is it? 1. And some of you may need to write those ones in to help you remember. So when you distribute that, it goes to both. So again, if I had xy to the third, what would that be? Perfect. X to the third, y to the third. It goes to both. And again, exponents only like their own kind, so they only go to other exponents. Right? The negative exponent property. We went over the problem on the homework like this one. I don't like negative exponents. If you leave them, it's considered not simplified. So they just move. Right? So if it's a negative, technically right now that's on top, right? It's going to move to the bottom. If it's negative on bottom, it's going to move where? To the top. Right? If you're dividing, again, exponents only like their own kind. So exponents go with exponents. But when it's a division problem, they subtract. So if you had x to the fifth over x squared, that would be x to the third. And again, a nice way to think about that, x to the fifth means you have 5 of them. X squared means there's 2 of them. And can't we cancel things that are the same on top and bottom? So it's like I'm canceling this one with this one and canceling that one with that one. How many are left? 3. So that's how I know there's only 3 left, x to the third. I remember very vividly sitting in class in high school, the very first test I ever took on exponents, and trying to remember all the properties. And I couldn't always remember what the properties were, but in my mind I could do this, or I could write that out and be like, oh yeah, okay, I just have to subtract them. But sometimes it's nice to fall back on those basics so that you can just kind of reason through it as opposed to memorize the properties. Okay? All right. Ooh. I didn't even know I could shift that. All right. The power of a quotient property. Sorry about the line on there. Same idea as before. It distributes. It's going to distribute to the top and the bottom. Anything to the 0 power equals 1. Anything. My smartboard to the 0 power equals 1. If I want to get rid of Donnie, can I raise him to the 0 power? What happens to Donnie? Bye-bye. Donnie's gone, and there's just a 1 standing there. Is Donnie still there? No, he's gone. Bye, Donnie. Sorry, you're sitting right in front of me. All right, so things to kind of keep in mind, okay? Because some people like, oh, x to the 0, that's 1, so it's x to the first. No, it's gone. Bye-bye, Donnie, right? Keep that in mind. Sorry, all semester long, it's going to be bye-bye, Donnie. He's going to be gone. It's how you get rid of something. Raise it to the first. It is gone. And just a 1 is left there, okay? Okay, so simplified expressions do not contain blank exponents or blank as an exponent. What kind of exponents are we not allowed to have? Negative. So they do not contain negative exponents. If you see negative exponents, what should you do? If it's negative on top, where am I going to put it? On the bottom. If it's negative on the bottom, move it up to the top. Okay, so we got to get rid of those. Or I can't have blank as an exponent. 0. What happens if it has 0 for an exponent? Bye-bye. Gone. It's just 1. Just literally the number 1. It's not Donnie to the first. It's gone. Bye-bye. All right. It has exponents that are blank numbers. We want negative numbers for exponents? They're positive. Yeah, they are positive numbers. Have number bases with an exponent of blank. So in other words, would you leave 4 squared? No. What would you tell me that is? 16. What's the exponent on my 16? It's a 1. Right? So in other words, don't leave 4 squared sitting on there. Right? Now, if it was like 90 to the 30th power, I'd probably leave that one 90 to the 30th, right? Because that's an extreme number. But like 4 squared, that's 16. Actually, multiply that one out. And it has fractions that are simplified. I do take points off if you leave fractions in your answers that are not simplified. Okay, if you leave me 2/4, I'm taking a point off. That's a half. Okay, so just make sure you simplify. All right, so now we're going to dive into a bunch of examples, looking at all these properties. I'm going to kind of slowly keep building and throwing more at you, all right? So number 1, 2x to the 3rd, y squared, all of that to the 4th power. What's the first thing we should do with that? Distribute. Does this 4 distribute to this 2? How does it distribute to the 2? Yes, that 2 is an exponent of 1. That is where most students will lose this problem. They either just ignore the 2 altogether and bring him down and don't do anything to him, or they multiply 2 times 4 and tell me it's 8. Don't do that. Right? Exponents only go to exponents. So that's going to become 2 to the 4th. We're going to have x to the 12th and y to the 8th. Remember, think about if I asked you to distribute, what operation do? You multiply. Yep, you're multiplying. Is that good? Perfect. Circle it. I'm done. I have to simplify. What's 2 to the 4th? That is 16. Good. So 16, x to the 12th, y to the 8th. All right, as we're going through, guys, if I'm moving too fast at any point, just raise your hand and be like, give me that motion of like slow down, you're lost, something, okay? Don't let me keep flying if I'm way too fast for you. Okay, number 2. Now, with the exponents, guys, there's different ways to attack problems, okay? Some students look at this, they freak out, and they automatically get rid of that negative first. Some students look at that, and they're like, oh, it's a negative exponent. Yeah, I'll deal with it later. Let's distribute first. Neither one of them is necessarily wrong, okay? You can do things in different ways. It's whatever you're comfortable with. Me personally, I look at that, and I'm like, oh, I have to distribute. That's what I would do first, okay? So if you do things slightly different than me, it's not necessarily wrong as long as we end up with the same answer at the end, okay? So does this negative 2 go to the 5? Does it become negative 10? No. What's it become? Let's start there. It becomes 5 to the negative 2. Let's go one step at a time. I know so many of us, we like to be like, let's do this. I'm going to do like 6 steps in one. I'm going to write it down, right? some of you like to try to do that. And I'm like, whoa, like you lost me a little bit. Yeah, I've seen that a lot too. People are like doing 12 steps in their head, and they're like, yep, there it is, 63, and they're done. I'm like, I have no idea what you did. It's wrong, but I don't know what you did. Okay, guys, I give partial credit. So if it's like a 5-point question and all I see is an answer and it's wrong, -5. But if I see your work and I'm like, oh, you lost one negative sign right there. Oh, -1. Okay, so please show me your work. I like to give partial points for you. All right, so but one step at a time. So that went to there, became 5 to the -2. Okay, here it's going to give me a to the +6. Good, because 2 negatives when I multiply makes a positive. And then my b to the -8. All right, from here, see the negative exponents? I don't like them. They go to the bottom. Okay, so if you want to distribute first, so if you're somebody who likes, I need steps, right? You're like, I can't keep this straight in my head. Step 1, I would distribute. Okay, so if you're somebody who likes step, something to fall back on, I would distribute first. Now, the next steps depends on who you are, what your comfort level is. Some people on the next step, they're like, I hate negative exponents. Let's get rid of them as soon as you can. Great. Some students, if there's like terms they can put together, some people will clean those up next. So it's up to you what you prefer. Me personally, I take care of like terms next. We don't have any in this problem, but and then I would do my negative exponents. So again, totally up to you where your comfort level is. Just so you know, my preference, I distribute, I take care of anything that's a like, and then I move my negative exponents. It's all right. I know, they make all kinds of weird noises. It's okay. All right, so what needs to move? Good. So that becomes 5 squared, and the b to the 8. What happens to the a? Stays on top. He doesn't need to move. Yay, good. Circle it, done. Simplify. 5 squared, 25. So we have a to the 6 over 25 b to the 8. Yes. Why does it? Okay. Just because somebody made up a rule and it just kind of went that way? No, that's not really why. It really isn't why. Should I tell you that, or should I tell you mathematically? Okay, let's do mathematically. All right, let's think about it this way. If I had x to the 2nd over x to the 5th, we'll come back to those x's example we did earlier. Okay, so looking at this, your rules would tell you 2 minus 5 is -3. So you would tell me this is x to the -3, right? But if we worked it out how we did earlier, x over x, and that would be 5 of them. So then you'd be like, all right, I can cancel this one and this one. I can cancel this one and this one. Where are they? They're on the bottom. So that's 1 over x cubed. So if I do the same problem legally 2 different ways and get different answers, what must be true about those answers? Means they're the same. Right? Legally, those are our rules. Right? Oh, yeah. We have like math jail in here. I keep saying I'm going to build like a little jail in the corner every time you do something wrong math. Maybe. So you're really close to it, so you know. But yeah, since I followed my rules and got this, we thought about it the long way and got this. That means this is the same as this. Yeah. But I mean, like, do you see legally how I did it both ways, though? It means they're the same. All right, number 3. It's just 1. Do I need to distribute that? No, it's this entire thing to the 0 power 1. Just like, remember Donnie? Bye-bye, Donnie. Yes. Any other questions on 3 before we get to her question? No, you're fine. Okay, what about number 4? No, it only goes to the one it's attached to. Okay, hold on. No, you're fine. We got a lot of questions going on here. Yeah. Okay. All right, so a couple things, some things are kind of brought up there. First off, she asked about where that exponent goes to. Exponents only go to whatever they are right next to. Like, and this is going to bring up a couple different things on this problem. So whatever it is directly attached to. So on this one, it's only attached to this parenthesis, so it only goes to this one. Now, when it comes here, smooth. Yeah, she put herself in jail. All right, so when it goes to the -7, and you write this down, if you write -7 to the -2 like that, that is something different than if I wrote -7 like this. Did you guys know there's a difference? Some of you may have. There's a difference. Rule of thumb. I'm going to throw this out now. This goes for all semester long. If it's a negative number, if you're not sure, put it in parentheses. Okay? And we'll talk about that in a minute. Kind of hold that thought. But what I want to see is parentheses around that negative. Okay? All right, so when it comes here, we're going to have m to the and n. Does anything go to this? Do I need the parentheses around it? It's just saying that it's being multiplied. Great. If I don't put the parentheses, it still is implied that it's multiplied. So you will learn about me. I am a lazy mathematician. If I can write less and do less, I'm going to do less. Okay? And I will pass it along to you as we go through the semester. I'm a lazy. I don't want to write it. I ain't going to do it. Okay. So from here, again, you have some options. Some students like the like terms next, and that's probably where I would go. Okay, notice that you have m's that are the same. What do we do with their exponents? You add them. The only time you multiply exponents is when you distribute. Okay? So we're not distributing, we're just collecting stuff together. So we're going to have an m to what power? -5, because there's a 1 there. -6 and 1 is -5. Good, and then you have n's, which is cubed. -4 plus 7 is 3. And I still have this -7 to the -2. Okay, again, one step at a time. Don't do 7 things in one step, okay? All I did was put my like stuff together. That's all I did. From there, yes? No, huh? Nope, I'm just trying to help you guys out so you know what on earth I'm doing. They are squiggles, but no, you don't have to. I'm just trying to show people so you know what I'm doing. Yeah, if you just write from one line to the next, I'll know what you did. All right, from there, negative exponents, I don't like them. What do I do with them? Put them on the bottom. Yeah, I got to move them. So this guy's going to the bottom. Now it's -7 squared. My m comes to the bottom. What about the n? Stays on top. He's positive. He doesn't have to move. Good? Done? Oh, what's -7 squared? -49 or +49? It is a +49. So n to the third over 49 m to the fifth. Now, let's backtrack to where I was like, those parentheses make a difference. How many of you have a calculator with you today? Okay, if you have a calculator, go ahead and pull it out for me. All right, one thing I want you to look at is the difference if you type this versus this in your calculator. It makes a difference. It's a trap. What is this first one? That's -49. And that's a +49. What I tell you about exponents, what do they go with? They go with whatever they are attached to. So your calculator, when you type this in, it reads it as this 2 is only on the 7. It doesn't read it as being attached to the negative sign. This one says, hey, stupid, the negative goes with my 7. Please keep it with it. Right? I mean, come on. You're like, if I put a negative in front of it, it means it goes with it. But your calculator's being smarter than you want it to be right here. So rule of thumb, if you're not sure, put a negative in parentheses. Right? Yes, ma'am. Mm-hmm. It would stay there. Yeah, that's a great question. If the 49, if this was negative, would it move it back to the top? No, it wouldn't. Okay, only negative exponents move. Great question. Because a lot of students do that. They're like, oh, it's -3. I need to move that. It's not an exponent. Don't move it. Okay, only exponents that are negative move. We good? We got this? All right, moving on. Number 5. Kind of just answered that question, didn't it? Number 5. Do I have to distribute anything? Is there any like terms? Do I have any negative exponents? Okay, so what moves? Does the -2 move? Why not? It's not a negative exponent, right? I don't care that the number's negative. So the -2 stays, the x stays, and what happens to the y? It comes up, and it becomes y to the cubed. You can if you want, but you don't have to. I'm that lazy mathematician. It's implied that it's over 1. If you put it over 1, will I count you wrong? No, I won't. It's just like if you prefer to see x to the first, that's okay. I'm just lazy. I don't want to write it. Okay? All right, how about number 6? Anything to distribute? Any like terms? Yes. And this is where people are like, yeah, I don't know what to do with that. Right? Would it help if I rewrote it like this? Now do you know what to do with it? Does it mean the same thing? It means the same thing. It's just like we assume that this is over 1, right? So then all I did was like, okay, there's the top, there's the bottom. If I rewrite it, students are like, oh, yeah, I got you now. So what like terms do we have? The h's. What do I do with their exponents? And 6 minus 4 is 2. So h squared, k to the 5th. No negatives. I don't got to move anything. Now, a question always comes up with students. When I'm subtracting exponents, by default, where does it go? To the top or to the bottom? Yes. I hesitate telling you a solid yes on that, but I know where you're going with that. For example, let's come back to my x to the 5th and my x cubed versus x cubed on top, x to the 5th on the bottom. Let's talk about the difference there, okay? By default, they go to the top. However, what she said about where the biggest number is technically true as well. Because if I would subtract these, 5 minus 3 is 2. By default, it goes to the top. Is it okay to stay there? And where's my bigger number? On the top. Okay, here, 3 minus 5 is -2. So by default, that would go to the top, but it's negative, so it would need to be moved to the bottom. So where's the bigger number? It's on the bottom. So did it end up where the bigger number was? Yeah. But by default, they go to the top, and then I'm like, oh, it's negative. So then I ended up having to move it back down. Okay, but we just need to keep that in our heads, because we get some problems that are like huge, lots and lots of parts and pieces. By default, they go to the top. Then sometimes you have to move them. Okay, but by default, they go to the top. Okay, here we go. Number 7. What do we do first? Distribute. Yeah, it's always first thing. Let's distribute. All right, so when we distribute, what are we distributing to? Everything. So when I distribute to the 3, does that become 9? No. It does become 27, or you can write it 3 to the 3rd if I'm going to go one step at a time with you, which is totally fine. I'm going to go one step at a time. When you distribute, what operation happens? You multiply, right? If you're right, like if I would have given you like 3 outside of x plus 2, your first instinct would be to, you distribute and you would multiply. Yeah, anytime. No, you're fine. You're rusty. All summer off. I totally get it. All right, so 3 to the third, do not make that 9, because exponents only like their own kind, right? They don't multiply by the big numbers. They don't like that. All right, so then we get a to the third, because what's the exponent on the a? There's a 1 there. And then c to the, do I distribute to the bottom also? Yes, because that's all in that parenthesis. So we get 5 to the third. Perfect. A to the negative 18. So all I did at that step was I distributed, which means I multiplied exponent to exponent. Okay? All right. The next step, and again, depending on your comfort level, personally, at this point, I would do like terms. Some students are like, I don't like negatives, and they like to move them right away. It does not matter. Whatever you're comfortable with. Okay? But if I go with my preference, which is like terms, what's a like? The a's, right? I can do the a's because they're the same. According to my rules, what happens to my exponents? What do I do with them? I subtract. So what is 3 minus negative 18? It's 21. Be careful. When I write it like that, usually people are like, oh, yeah, 3 minus a negative. That means they're pluses, right? So that forces that. So I'm going to have 3 to the third, a to the 21st, because by default, where do they go? On the top. I have a c to the 12th, and on the bottom, I still have a 5 to the third. Okay? And then I have to do what? I have to simplify. What is 3 to the third? 27. Oh. There we go. I just meant to try to move Mickey out of my way. All right, a to the 21st, c to the 12th, over 125. All right, talk to me. If I lost you somewhere, please ask. You just walked in. All right, so first thing, always distribute. That means you're multiplying your exponents to other exponents. Okay, so kind of a recap. We distributed the 3 to all the pieces inside the parenthesis. That was the first step. Then I went ahead and saw I had like terms. If I'm dividing, that means I subtract. So 3 minus negative 18, right? 3 minus a negative, made that a 21. By default, it goes to the top. And then I just rewrote what I had left. And then I can't leave numbers with exponents. I just changed those to my last step. Now, if you're comfortable and you're like, all right, when you distribute here, could you have written 27 right here? Yeah, if you're comfortable, by all means, write the 27, write the 125. I'm okay with that. Questions? Yes. Mm-hmm. Yeah, right here. That's okay. Totally fine. There are some steps, like if it's me personally, if I'm sitting down to work through this problem, I'm going to put a 27 and a 125 here. But I'm still going to see this, and I'm still going to see where I put those A's together on this step. And that's okay. If you go from here to here, I have a problem. Okay? I need to see a little more than problem to answer. I need to see at least 1 or 2 steps in between there. Okay? Just so I have an idea that you didn't just go, what do you got? And write that down. Okay? Come on, you. All right. Number 8. What do you want to do first? Distribute. You guys getting the hang of this? We distribute. So what do we get? D to the negative 1. E to the negative 6. All right. Where is this stuff located? Do I have to keep it way over here to the right? Is it on the top or bottom? It's on the top. Could I throw it on top right here? Yeah, I absolutely can. Goes back to that last problem, right? Where you're like, where is it at? Just put it all together, top fraction, bottom fraction. All right, so I distributed first. Next, do you have any like terms? Yes, let's put our like terms together. All right, I have like terms right here with my D's. What do I do with their exponents? I I add them, right? It's a multiplication problem. They're on the same level. So these get added. So d to the 6th. And then I have e's. Now they're being divided, so they are subtracted. 3 minus negative 6, 9. By default, it goes to the top. Does anything then need moved? No. Now the question always comes up, what if I wrote my answer like this? Is that okay? Yeah, it's okay. You're multiplying, it doesn't matter. Now, I will tell you my preference is alphabetical. I'm a bit OCD at times. My preference would be in alphabetical order. But is it wrong if you flip them? No. Number 9. Oh, no. The only time you cross multiply is when there's an equal sign in between. Yeah. No, it happens every year. Somebody's always like, oh, just cross multiply. No. I'm happy you know that term, but you're using it wrong. Don't do that. It's just like if I ask anybody, what do you know about graphing a line? What's the first thing that somebody tells you? What equation do you think of? You're going to make my point not. There it is. Somebody can always spew that out. And I'm like, what does it mean? I don't know. Something about lines, like that, you know. So one of those things. Same thing like, can you cross multiply? No, stop it. Don't do that. Fine. All right, but it's a multiplication problem. We've been doing these this whole time. All right, I just happen to have tops and bottoms on both. It's all right. Do I have anything to distribute? No parentheses. Nothing to distribute. Do you have a question? You're fine. Yeah? Yeah, you sure can. He's like, can I just make this one big fraction? Yeah, I really can. I can. Yeah, somebody forgot part of the line in there. It's totally fine. All right, so I didn't have anything to distribute. Do you have like terms, things you can put together? Yes. Now, here's where people kind of panic. So they're like, oh my God, there's 2 y's on top and there's 1 on the bottom, and I don't know what to do. There's too many y's, and they freak out, and they just kind of leave it blank and they move on. Right? Come on, you've all been there before. You're like, I don't know what to do. So you just do nothing. Don't do that. All right, clean up the top, clean up the bottom, and then put them together. Okay? Right? Right? Do the top, do the bottom, and then eat the sandwich, right? All right, so on the top, what can I put together? The y's. So I'm going to have a 3. I'm going to have the x to the 5th. What do the y's become? Y squared. All right, so I clean the top. What should I do next? Clean the bottom. What's the same on the bottom? What do I do with the 15 and the 4? You multiply them. Are they exponents? No. Exponents would have been added. That's just 15 times 4, which is 60. And I have a y squared. All right, so I clean the top, clean the bottom, and now eat your sandwich, right? She so delicately put that. Yeah. Okay. No, I'm glad you asked. No, we're not done. We're not done. He's just lost on what I did. All I did was put the top stuff together. On top, I had a y here and a y here. So y to the first is y squared. I just put that stuff together. So if it's the multiplication problem, you add your exponents. So that's all I did on the top. Does that look weird to you? Yeah. That's the only reason I rearranged it, because that looks weird. Mm-hmm. Technically, it still is, because what happens to these 3 things? If you see stuff sitting next to each other, what do we assume is happening to them? They're being multiplied. I just moved it because this looks weird. X to the 5th times 3, like I did 3x to the 5th. The 3 is its own piece. It's being multiplied by the x to the fifth, which is then being multiplied by my 2y's, which is y squared. When you multiply, does it matter the order? No, that's okay. I'm glad you asked. No, I'm glad you asked. Because sometimes I do things I assume that you know what I'm doing and you don't, and that's okay. Sorry. No, I'm glad you asked. Yeah, guys, when you multiply, when you write things down, like the order doesn't matter because you can multiply in any order. If I multiply 2 times 3, what do I, 6, but what's 3 times 2? Still 6. So the order doesn't matter. We just like, this looks weird. We're used to seeing the number out in front. That's the only reason. Does that help? Are we good? Okay, good. Yeah, it just looks weird. And then on the bottom, 15 times 4 is 60, and I had the y squared. Okay. All right, so we clean the top, we clean the bottom, and now eat the sandwich. So what happens on the sandwich? The y's cancel, good. And again, if you followed your properties, 2 minus 2 is, and anything to the 0 power is, bye-bye, Donnie. It's gone. Because if I multiply 60 by 1, does it change it? Doesn't change anything. So bye-bye. It's gone. Bye-bye, Donnie. All right. Good? Just like that? Or can I simplify again? 3 and 60 can both be divided by 3. So 1x to the 5th over 20. If you like the 1 sitting there, if this makes you feel better that you know what you did, you divided them both by 3, you can write the 1. Again, I'm lazy. I probably won't. Yes? They're not exponents. Yeah, it's just like if I would have given you 2/4, you wouldn't leave that 2/4, right? You change that to 1/2. It's not that you subtracted them, it's that you simplified your fraction. Yeah, so that's the hardest thing is keeping track of like, okay, if it's an exponent, I do these things. And if it's the coefficient, the big number, it does not follow exponent rules. It's got its own rules. Yeah, that's the hardest thing to keep track of. Great questions today, guys. Great questions. All right, number 10. All right, we're almost there, guys. Number 10. Again, you got the fraction times the fraction. How can I think of it? One big fraction bar. Yeah, we can just make this one big fraction bar. Think about those steps we wrote down. Number 1, do I have anything to distribute? Yes, let's do that first. Okay, so it only goes to the parenthesis it's attached to. So I have 3 to the negative 2, m to the negative 2, and n to the positive 4. All right, this other stuff, does it still come down? Yeah, that's still on top. And I'm going to go just one step at a time here, guys. I'm just going to rewrite the entire bottom. I don't want to confuse anybody. Okay, so the only thing I've done at this step was I distributed, and then I just rewrote what was left. Okay, so we can kind of talk through one step at a time. All right, so if I'm thinking at my steps, step 1 was to distribute. Step 2, do I have any like terms? Yes. And again, how do we clean? Clean the top, then we'll clean the bottom, and then we'll put that whole thing together. So let's clean the top. Does I have a like term with my 3? No. How about the m? Yep, I got another one right there. So my m's, that's going to give me m to the 3rd. And again, there are different ways you can attack these. I'm just trying to systematically kind of give you what I would do. All right, and the n didn't have anything to go with it. So I just cleaned the m's on the top. What can I clean on the bottom? Oh, yes, thank you. I totally lost my 18. Sorry. Sorry, I just stick them at the end because I forgot them. Good. On the bottom, I have some ends I can put together. Can I also do something with these numbers? I can multiply them. Now, I know the question's going to come up. Why didn't I multiply the 3 and the 18 on the top? Yes, that 3 has an exponent that I can't do anything with yet. Right? On the top, I had a 3 and an 18, but this 3 is an exponent. I have to take care of that before I can actually put it together. Okay, that's why I didn't touch it yet. But on the bottom, I did leave it, these didn't have exponents, so I just multiplied those. I have an m. And then my n's, I'm going to have n to the 7th. Okay? Questions so far? I don't want to lose anybody. Tried to clean up the top, the like stuff, and I put the like stuff on the bottom. All right. Do you have negative exponents? Should I move those? I can move them here. Could I clean it like the sandwich first and then move them? Yes. Do you have a preference? It really doesn't matter. What do you guys want to do? What? She wants to move the negative exponent. Let's do that. So the only negative exponent I have is at 3. So let's move the 3. All right, so it's going to be 3 squared on the bottom now. What is 3 squared? Okay, can I write 9? Will I throw you if I just change this to a 9? Right? So this I'm moving down. That's why it became a 9. And I still have the 20. I have the m, the end of the 7th. And I still have all this stuff on top. I'm going to move my 18 to the front only because it looks weird in the back. Okay? Not to freak you guys out again. What? That's 180. Yep. Ooh, that jumped a long ways. Yeah, so again, one step at a time. I'm not doing anything to the top. But the bottom, they wanted to put that together. So that gives me 180. And I'm going one step at a time. If you are comfortable and can do a couple things at once, I'm okay with that. But I just don't want to lose people who were like not knowing what's going on with exponents. All right, so I look at this. Before I circle any final answer, my brain is always looking at, is it simplified all the way? And it's not. What can I still do? I can simplify my fraction. 18 and 180 can both be divided by 18. Right, just so you can see what I'm doing. Divide by 18, divide by 18. So that gives me 1 over 10. Good. I have like terms. My m's. What's the exponent on this one? So 3 minus 1, m squared. By default, where do they go? To the top. And the n's? See, she can do 2 steps in her head. I'm okay with that. For those of you who cannot, 4 minus 7 is negative 3. 10 has a mind of its own. So by default, they go to the top. But where do I need to put that then? At the bottom. So m squared over 10n to the 3rd. And again, we went probably a really long, one teeny tiny step at a time. If it's you and you're comfortable, you probably will do a lot more of that kind of in multiple, combine some of that, and that's okay. But do you see how I'm always looking for, first of all, distribute, but then I'm looking for, do I have negative exponents that need moved, and do I have like terms, things that can be simplified? I'm constantly reassessing. Every time I think I'm done, look at it again, oh, there's still more I can do. Do it again. Okay, is there still more I can simplify? Do I still have like terms hiding in there? Isn't that nice, though? Like, it's a teeny tiny little answer. Genie. All right, last 2, guys. So number 11. Right away at number 11, I see something, and I'm like, yes. S to the 0. What happens to it? Bye-bye, Donnie. It's gone. Right? Technically, it's a 1, but if I multiply by 1, does it change anything? No. First thing I always do personally, when I see something to the 0 power, I'm just crossing it off. It's like it's not even there. Okay? All right, so what do I do next? I distribute. Now, this is set up where it looks a little weird. Where is that whole parenthesis? Where is it located? Technically, it's on the top. Yeah. Well, you want to move it. What do you mean by switch it? I want to make sure I know what you're asking me before I. What do you mean flip it? You could at this step, yeah. Yeah, I'm cautious when I tell people that. Technically, you could take this entire thing, move it to the bottom, and make that a positive 2. You could do that. I'm not going to, only because I think I cause more people issues than if I would just distribute and kind of deal with it later. But you can. All right, so I'm going to rewrite what I already have. So I have the 2r squared. I have the t to the 9th on the bottom. And then let's distribute this, right? This is like it's over 1. So because r to the negative 6, s to the negative 2, and t to the 8th. All right, so all I've done at that step is I distributed, and that first fractional part, I just kind of wrote that to start with, and then I put all that stuff on top of it. All right, and again, your choice. You can move the negative exponents here, or you can do like terms. Personally, I do like terms next. Do you have any like terms? Yeah. So let's go ahead and clean up some like terms. What do you want to put together? Yeah, I put the r's together right in here. So the 2 is going to stay there. When I put the r's together, what do we get? What? Negative 4? By default, they go to the top. Does the s go with anything? No. And then the t? What do I do with their exponents? Subtract. 8 minus 9 is negative 1. By default, it goes to the top. So now when I look at it, do I have things to move? What moves? The r, the s, and the t. Does the 2 move? No. Right? Because what's its exponent? Technically, it's a 1, which is positive. Because a lot of times students are like, oh, it's connected to the r. No, it's not. It's being multiplied by the r, but it's not directly connected to it. So the 2 stays. The r, the s, the t, they're all going to move down. So 2 over r to the 4th, s squared, and t. If you like t to the 1st, you can. I'm just lazy and don't want to write it. All right. Number 12, on your own. Let me give you a couple minutes. Try number 12. All right, guys, let's go ahead and talk through number 12. A couple things I kind of noticed as I walked around and checked out some of your answers. So first thing, obviously, let's distribute. So we should have a to the negative 8. That's a 4, right? Sorry. When I'm up really close, it looks even different than from your paper. So then I get b to the negative 14, c to the negative 12, all over a to the negative 6, b squared, and c to the 6. So there's step 1. That's what you should have on your paper. If you don't have that, we messed up right away. All right. From there, I'm going to look for, do I have like terms? Okay, and I definitely have like terms. So putting my a's, negative 8 minus negative 6 is negative 2. By default, they go to the top. So I'm just going to write it by default. So my b's, negative 14 minus 2 is negative 16. And then my c's, negative 12 minus 6 is negative 18. And then all of those are negative, so they all go to the bottom. So you're going to have an a squared, a b to the 16th, a c to the 18th. What has to be on top? There has to be a 1 there to hold everything down. So I saw a lot of people's papers as I walked around and checked them out. A lot of you wrote, you had the a squared, b to the 16th, c to the 18th, but you had just that. Like you forgot the fraction and the 1 on top. You got to have that to push it down to the fraction. Okay? Show of hands, how many got it right? Good. The first time. Once you put the 1 on. Okay, good. Guys, one last thing. Guys, real quick, one last thing, because I know some of you struggle to remember things and like these properties. MADS. I know it's not really a word, but MADS, think of it, you need to get MADS disease in math class, okay? It's a disease I want you to catch, okay? If you were supposed to, if it's a multiplication problem, what do you do with your exponents? You add them. If it's a division problem, you subtract. Maybe that'll help you remember. So if it's a multiplication problem, you add your exponents. Division problem, you subtract your exponents. So if that helps. Yes, I will come take a look at it.